Hello. I'm really happy to be here, first of all. And please focus on this name right now, because we didn't brand anything in this presentation. And this is the only time that you probably will see the name. Yeah, I'm Bruno. I studied architecture, as well as Ben. And actually, I didn't study architecture to become an architect. I always had the dream of actually 3D printing a house. And this was 12 years ago, and then you go through architecture school, and you are like, okay, I actually didn't learn anything. I didn't learn how to build a house. I just learned some concepts, and these concepts are nice. But how can I be more productive? So if you look at architecture today, you see a lot of modernist buildings. You see a lot of things that you could have done 100 years ago, just with a bit new tech. But you don't see the architecture changing anymore. These are not real buildings. These are not renderings. These are AI-generated images by Midjourney. You have seen a lot of these images throughout Puzzle X, through presentations. They basically use words and feed an AI with these words, and this AI generates these images. And these images are amazing. You can come up with a lot of iterations. This is by Matías del Campo, a Chilean architect. And it would be amazing if you could build like this. And this is also what I was imagining when I started out my architecture journey, was, can we actually change architecture, change it for the better, make it more sustainable, make it look different, make it more a home for humans? This is the first project that we are working on. We didn't use any artificial intelligence or something like this. We basically developed a technology first that we are using to help an architect realize this facade that should remind you of the neural network in your head. We made an algorithm that actually opened up the views when you would sit down and would close down a bit more up top where you would need protection from the sun. Of course, a building like this is a rendering, it's right now in fabrication, would be needed to be calculated completely different. So we used technologies that you would actually find in rocket science, where you would basically additive manufacture parts of a rocket and would want the rocket to be as lightweight as possible and withstand certain load cases that you were not able to calculate by looking into a book and reading about formulas. So you would simulate the main load case and basically find out where your structure is the weakest, and then basically take off material that's actually not needed. So this is one of the first parts of this facade that we are right now producing. It's 3.5 meters high. It's roughly 1.5 meters wide, and it's roughly 40 centimeters thick. It's made out of ultra lightweight concrete, and it's produced in 2 hours. And we are doing this with a novel additive manufacturing method that basically uses a powder bed system and activates your cement inside the powder only locally where it's needed. The extra material is then sucked away and reused for later batches. And this material is ultra lightweight, but we also only use the material that's actually needed for the part to function as a facade. And there you, for example, have wind load cases, so it needs to be strong. It needs to also withstand the natural effects that happen outside. Our company, Additive Tectonics, that you only saw in the beginning, is basically founded in 2020, so in the middle of the pandemic. And we really had a lot of time to focus on ourselves. And we built this hall, and we built this material mixing station, and we developed this new machine together with a construction machine developer. Concepts of this were already developed in university at TU Munich, and basically I brought these into industry. And this machine is, as you see, the print bed is 4 meters long, 2.5 meters wide, and 1 meter deep. And a thing like this we can print in around 5 hours. So this makes this machine the fastest 3D printer on the planet. But the most important thing is not just printing with concrete, because concrete is a resource that's not very sustainable right now. Of course, you could put these sustainability issues on the cement fabricators, because the cement fabricators are the ones that create this CO2 emission when they burn the cement in the very beginning. You could start to capture this and capture the CO2 and bring it back into your print or into a concrete part. But because they're not acting right now, we are looking actively to new material alternatives. So we're working with geopolymers in magnesium oxide cements. This is like an information. We basically call this econit so that people kind of understand that it's not a normal cement. And this type of cement can also bind wood. It can, like wood chippings, brick, sand or limestone, or whatever kind of works with your cement. So with that, we can actually print with wood and actually go further into like natural resources. We are right now also working on completely removing any binder out of the system and working with natural binders like fungi that can also work in these types of systems. Our most favorite cement is an ultra-lightweight cement, and this is actually made out of recycled glass, which is a company that's right around the corner. We are in Bavaria, in Germany, so there's a lot of industry, and we can take this material from them because they're actually using recycled glass bottles. Like these are glass bottles that went through their life cycle like 4 times, and now they can't be used for the manufacturing of bottles anymore. And we basically use this material, inflate it, and make out of it a very densely packable powder that we then later use to print with. Yeah, our printing system works like this. Like basically, you have this container that you slice up, and then here you see the printer running in a way. There you see how it activates the material locally, and then you can see that inside your part can be a completely different structure than outside of your part, which makes the parts even can be very complex and very delicate on the inside, and can be perfectly fabricated for your construction site. You then basically take it on site, assemble it, and you can create not just a very novel architecture with it, but also a new expression and a new way of how we construct and how we think architecture can be. In a thing like this, there can be all of your building services integrated. You can integrate your desks and these types of things. Okay. Yeah. So just to remind everybody about what it's all about. It's not about doing only fancy architecture or doing or making something that hasn't been done before. It's really about like trying to break out of this monotony of modernism. It's trying to make less waste, because we can actually put a lot of building functions into an element that only uses one material. So that means you can recycle it later in a very elegant way. We use less material, less people on the construction site, because on the construction site it just goes faster to assemble it, and we can actually handle the complexity that comes with digital building, because it means that you can't allow any mistakes to happen during your fabrication time. So we can actually take something out of a 3-dimensional model and put it directly onto the construction site. So thank you a lot. I hope you enjoyed the talk. And if you have any questions, please talk to me outside. If you want to know the name of the company or my name, talk to me outside. Thank you.